Hello students, how are you all? I hope you all are doing good. Yes, so we are back again with the next lecture of your chapter. What we were doing, motion in two dimensions. Okay, so what we have discussed in the last class, we were already discussing centripetal acceleration and tangential acceleration, which are the part of acceleration involved in any circular motion. And you all know circular motion is an example of motion in a two dimensions. Okay, so what today we are going to discuss. Before that, let's get an example. Yeah, before going into the main topic, let's get an example. Suppose I say, if you see as an athlete, if you see an athlete throwing the javelin, so what he do, he just throws the javelin like this. Yeah, he runs through his path and throws the javelin. So which path does the javelin follow? The javelin follows a curved path. If I say, yeah, javelin follows a curved path. Okay, and that curved path is actually due to the action of gravity, what we call as gravity of earth, and something known as air resistance. So that curved path taken by the javelin is something defined as projectile motion, which we are going to study in today's lecture. So projectile motion is another example of motion in two dimensions. After discussing circular motion, we are now discussing projectile motion in this lecture. So I hope this is clear. What is actually projectile motion? It is a special kind of, I can say, curved path taken by any body under the action of gravity as well as air resistance. If I give you another example, let's take an example of a basketball. Yeah, let's take the example of a basketball. The player who is playing basketball, if he tries to score a basket, what he will do, he will try to throw a ball like this. He will try to throw a ball like this. So what will be observed? The path of the ball will be curved. And I see most of you are basketball fans here. So all of you have seen that basketball movement, that it is actually getting a curved path. And that curved path taken by the body during a projectile motion is known as trajectory. Is known as trajectory, yeah? Trajectory of a projectile. Okay, done? Okay. Now let's start what we are going to see today in today's lecture. Let's see which topics we are going to discuss. I hope basic funda is clear, or basic theme is clear, that what is actually projectile motion, what we are going to study in today's lecture. Okay, so let's see. We are going to discuss these much topics today. Yeah, we are going to discuss these topics. Basically, get an introduction of projectile motion. Then we will see what is the maximum height attained by the projectile, its range, its condition for maximum range, and trajectory of projectile. That is the path taken by the projectile. Trajectory of projectile means path actually taken by the projectile. That's what I was talking about. If a player is standing here and he throws the basketball, the ball will follow this path. As you can see, this is a curved path. As you can see, this is a curved type of path, which is actually known as projectile motion. And this is known as trajectory of that projectile. The path, whichever path the body is taking, is known as trajectory of that projectile. Okay. Now let's see what is actually projectile motion. I already discussed that projectile motion is the motion of an object which is thrown or projected into the area. It can be thrown, it can be projected into the air, only subjected to action of gravity, that is acceleration due to gravity, and air resistance. But the thing is that we are neglecting air resistance. We are neglecting the effect of air resistance on these bodies, because air resistance is I can say inappropriate, or I can say you don't know the value of air resistance. We can't calculate exactly the value of air resistance, and its effect is not much significant if we are talking about general bodies which we are dealing with, which are moving near to the surface of Earth. So the effect of air resistance can be neglected near to the surface of Earth. That's why we are neglecting air resistance. So if we define that projectile motion is the motion of a body which is thrown or projected into the air, and the only force or the only acceleration of acting on that body will be acceleration due to gravity. That thing is clear? Okay, so we have got the basic idea that what is actually a projectile motion. It is an example of motion in two dimensions. Yes. So if you see in this picture, there is a ball thrown from a cannon in this picture. So the ball is following like a curved path like this. Again, the only acceleration acting on it is acceleration due to gravity. And you can see in the second picture, a monkey is being dropped, or a monkey is falling from a stem of a tree or the branch of a tree. So So this is again example of projectile motion, because the only acceleration acting on this monkey was acceleration due to gravity, which is given by small g. And in this case of ball also, the only acceleration acting on the ball is acceleration due to gravity, and whose direction is always downward, or you can say always towards the ground, or you can say, to be more precise, towards the center of the earth. Okay, so I think the basic idea of projectile motion is pretty much clear to you. Okay, now see types of projectile motion, that in which types or in which cases you can observe a projectile motion. So you can see there is a person standing on the top of a building or a cliff, and he's just dropping a ball. He's just dropping a ball. Okay, so this is again example of projectile motion. And a simple example of projectile motion can be like this. A person is standing on a building. He is throwing a ball. He's throwing a ball like this at any angle. Okay, he's throwing the ball at any angle like this. So the ball is following a curved path and hitting the ground like this. So this is again example of projectile motion. This is an example of projectile. This is again example of projectile. You can see a person is throwing ball vertically upward. So the ball will follow this path. Yes or no? This again is example of projectile motion. And this is the example when the person is throwing a ball obliquely. Yeah, when a person is throwing the ball obliquely. Yeah, so that is again example of projectile motion. So these are some basic cases where you will observe a projectile motion. That is the motion which is acting only under the acceleration due to gravity, as the air resistance is neglected. Clear? Okay, thumbs up if you got clear. Okay, now we'll get the basic idea of what is actually projectile. What is actually projectile? So suppose I am taking the case when the ball is thrown obliquely. When a ball is or object is thrown obliquely. Suppose this is ground. Suppose this is ground. Okay, and an object or a ball is thrown with an initial velocity u. Suppose it is thrown with an initial velocity u at an angle theta with the ground. So here in the projectile, we always try to measure, or we always measure by convention, the angle with the horizontal only. Okay, so suppose it is thrown like this, so it will follow a path like this. This projectile will follow a path like this and ultimately come back to ground. This is actually the part taken by the projectile, and that motion is defined as projectile motion. Okay, so if you can see, this is the velocity. So can I say this velocity can be converted into two rectangular components? Yes, this velocity can be resolved into two components, which is one is horizontal, which is given by u cos theta, and the vertical component, which is given by u sin theta. That is clear. So there are a few things to see, that its velocity at every point of time is different and always along the tangent of the curve. So the velocity of the projectile is different at different points, and it is always tangential to the curved path taken by the projectile. And the basic property, important property, is that at the maximum height, this is the maximum height, suppose this is the maximum height attained by the projectile. So at the point of maximum height, the velocity is horizontal. The velocity is horizontal. And if I talk about the thing that what is the acceleration along horizontal direction, suppose we are taking by convention horizontal direction is x direction and vertical direction is y direction. So what is the acceleration along x? So in a projectile, acceleration along x direction is 0. So if acceleration along x direction is 0, can I say velocity along x direction will be constant? Because acceleration is 0. So that's why in a case of projectile motion, the horizontal component of velocity always remains constant, because acceleration is 0 on a horizontal. So this u cos theta will remain as u cos theta during the entire motion of the projectile. What about the vertical acceleration? Vertical acceleration will be minus g. As you are going upward against the gravity, yeah, this vertical component is going upward against the gravity. So that's why I'm taking acceleration along y direction as minus g. So due to that acceleration, the vertical component of velocity will change place to place. Okay. Suppose I am talking about general point. Suppose this is a general point. So this general point will have two components. Okay. Suppose this is phi. So it will be u cos theta, because horizontal component of velocity does not change. Suppose this is vy, vertical component. So at any point of time, the projectile has a general velocity v, which is given by parallelogram law as u cos theta whole square plus vy whole square. Yes. This is the general velocity. And what about Vy? Vy will be, according to first equation of motion, Vy equals to u sine theta, that is the initial velocity along vertical direction, into time. Yeah, what equation you are using? Suppose we are using first equation of motion, so it will go like this: v is equals to u plus at. V is equals to u plus at. As you see, initial velocity was u sine theta along vertical, acceleration was minus g, and time is t. So this is vy. At any point of time, vertical component of velocity will change and horizontal component will always be u cos theta. So these are the basic properties of a projectile motion, that along horizontal acceleration remains 0, along vertical acceleration is minus g. At any general point, velocity is given by this, and the angle made by the velocity with the horizontal at any point of time, that is tan phi. At general point, tan phi will be given by vertical component over horizontal component. So that will be u sine theta minus gt divided by u cos theta. So in this way, you can also find the angle at any point of time that the velocity vector is making with the horizontal. Okay. Yeah, and velocity will always be tangential to the curve path. So I think the basic things are clear, that what is actually happening during a projectile motion. Yes, clear. Now we will see again a different case of projectile which is possible like this. Suppose a body is present at some height h from the ground initially. Yeah, now we are not throwing the ball from the ground, we are throwing it like this. So suppose you are giving it a velocity like this. I am giving you a horizontal velocity, suppose u. So it will follow a path like this. It will follow a path like this. Okay. So here again, acceleration along x direction will be 0 and acceleration along y direction will be plus g. Yes or no? Why? Because the body is going vertically downward initially. So that's why the acceleration is taken as g. So this is another case of projectile when you are throwing the ball from a certain height above the ground with the initial velocity u. So suppose at any point of time the velocity will be like this, and the basic concept is that the horizontal component of velocity will remain constant because acceleration along horizontal direction is 0. And suppose this is vertical velocity vy, so I'll write vy as u plus at. What is initial velocity along y direction? It was 0 because initially the ball was having only horizontal component. So can I say initial velocity, final velocity along y direction will be v equals to u plus gp. Yes or no? That is giving you vy equals to gp, and x component will be u only because acceleration along x is 0. So can I say at any general point v will be equals to vx square plus vy square, that we have already learned by the parallelogram law, that how to find the resultant. And suppose it is making an angle phi with the horizontal, so then tan phi will be vy over vx. So this is the general difference between the two projectiles we have seen. Yeah, this is the general difference between two projectiles we have seen. Okay, so I think this case is also clear to you, that how to see this kind of case. The basic thing or important thing is to remember that in a projectile motion, the acceleration along horizontal will be 0. Acceleration along y will be minus g in case of throwing the ball from the ground, and it will be plus g in case of throwing a ball from the top of a building or from any height edge. Okay, so that is the basic case. Clear? Yes. Okay. Now see this again, coming back to this, what can I see? I am trying to do a simpler thing for projectile motion. Yeah, I am just splitting the projectile motion in two parts, one along horizontal velocity and one along vertical velocity. One along horizontal velocity and one along vertical velocity. Okay, I'm just trying to just bifurcate this projectile, or just resolving this projectile into two parts. One is along horizontal, another is along vertical. So that is the case. Okay, that is the case. So we were basically bifurcating. Yeah, we were basically bifurcating these two things, that one is the vertical component of velocity and one is the horizontal component. So if you want to see, there is three things. One is motion along vertical, one is motion along horizontal. So motion along vertical is governed by this component u sine theta. Okay, and motion along horizontal direction will be governed by this component u cos theta. That thing I want to say, that if you study or if you try to solve the problems of projectile by bifurcating into two perpendicular directions, that is, one is horizontal, another one is vertical, then it will make the things simpler for you. Yeah. Now these things we will see while deriving some basic terms associated with projectile. So first is the maximum height attained by a projectile. What do you mean by maximum height achieved in the trajectory? That maximum height is this maximum height. Maximum height is the actually maximum height attained by the projectile during its complete motion. So this is the point of maximum height. Okay. So as I already told you, you have to bifurcate this projectile motion. Yes or no? You have to bifurcate this projectile motion. Who is deciding the vertical height? Who is taking the ball upward? If I say, who is taking the ball upward, horizontal or vertical component? Obviously vertical component. So suppose this is the velocity. So the vertical component is deciding the maximum height, which is along the vertical direction. So if you try to study these components by bifurcating the projectile into two directions, the things will become simpler. Suppose in the vertical direction, the height is h, initial velocity is u sine theta. Okay. What is the maximum height? And you already know at maximum height, vertical component of velocity is 0. So can I apply third equation of motion along vertical, that v square equals to u square plus 2as? Yes, because final velocity at maximum height h is 0. Initial velocity, that is vertical, which is given by u sine theta whole square. Acceleration is minus g, and s is maximum height. H is maximum height. I'll write 2gh equals to u square sine square theta. That will give you h is equals to u square sine square theta by 2g. So this is actually the maximum height attained by the projectile when the projectile is fired or thrown at an initial velocity u and at an angle theta with the horizontal. So see, the things have now become simpler. The things have now become simpler by assuming that vertical height or the maximum height along vertical is decided by the vertical component. And then you can simply apply the equations of motion learned in one dimension motion. This is actually one dimension motion in vertical direction, which is governed by the u sine theta component. So that's how we are calculating maximum height. So I think this concept of maximum height is clear to you. Okay. Now the next thing is range, or you can say horizontal range. Horizontal range, which is generally shown by the symbol capital R. So horizontal range, if I define, you can see different types of projectile here, throwing at different angle. So you can say this is the horizontal range for this projectile. This is the horizontal range. So how can I define the horizontal range? Horizontal range is the distance from point of projection. Yeah, this is the point of projection, that is origin in our case. So horizontal distance between the point of projection and the point where the projectile strikes the ground again. Yeah, it goes into trajectory like this and come back to ground and strike at this point. So the distance between point of projection and the point where the projectile strikes the ground is defined as horizontal range of the projectile. Or you can also say maximum horizontal displacement of the particle along the ground. Yes, maximum horizontal displacement of the particle along the ground. That is defined as range or horizontal range. Okay. So you can see this is the horizontal range. This is the distance along the horizontal. So that will be decided by the horizontal component of velocity, that is u cos theta. Yes or no? This is the horizontal range. So which component of velocity will decide? Horizontal component. So before getting into this range, we will see one more term. Before deriving the formula of horizontal range, we will see one more term which is given by time of flight, which is given as time of flight. So what is actually time of flight? It is the complete time. Yeah, it is the complete time of the journey, or I can say the time in which, or the time interval in which the projectile was in air. The projectile was in air. Suppose I am throwing this projectile from this point. It goes into curved path and comes back to the ground. So the time taken by the projectile from the initial point of projection to coming back to the ground, this total time is calculated as time of flight. This total time is calculated as time of flight. So this is another I can say basic formula of the projectile, which is time of flight, or I can say the total time of the journey of the projectile is defined as time of flight. Okay. So what can I say about time of flight? Who will decide time of flight? Obviously vertical component. Yes or no? I already told you to bifurcate these into two, u cos theta, u sin theta. So actually which component will decide? U sin theta, because u sin theta is the vertical component. Projectile will go in vertical direction and come downward. The case is this. So we are studying this projectile motion with a one component, u sin theta. So if I say the time taken by the projectile, if you study the motion in one dimension, what we say, that the time taken by the projectile or the body to go into maximum height is t, then total time will be 2t. Yes or no? Or I can say the time taken by the body to go into maximum height will be same as the time taken by the body to come into ground again. Yes or no? From ground to maximum height, suppose time t, then from maximum height to ground t, the time will be same. So that is the time of flight is calculated by twice of the time taken by the body to go from initial ground position to the maximum height position. So if I consider this as a vertical motion, we have already calculated maximum height h. Yes, and we know at maximum velocity or maximum horizontal or at the point of maximum height, vertical component of velocity is 0. Vertical component of velocity is 0. So can I apply first equation of motion in vertical direction, that v equals to u plus at? And you know at maximum height, velocity is 0 along y direction. What is initial velocity along y direction? It is u sine theta. What is acceleration along y direction? It is minus g, and time is t. So t will be u sine theta over g. T will be u sine theta over g. Now this is the time taken by the projectile to go from this point to maximum height. So the time taken by the projectile to again come back to the ground will be equal, yes. According to the motion in one dimension along vertical, time taken will be equal. So can I say total time, or I can say time of flight. Time of flight will be given by capital T equals to twice of small t. Yeah, 2 times of this time. So it will be 2u sine theta over g. 2u sine theta over g. So this is the formula for time of flight. 2u sine theta over g. So we have derived two formulas: range, which is given by the vertical component, this u square sine square theta by 2g, and the time of flight, which is given by 2u sine theta by g. 2u sine theta by g. So I think you are now clear about how to decide or how to find these components. Actually, you are not required to learn these as well. If you know the concept that time of flight is calculated by taking the vertical component, yes, maximum height is calculated by taking the vertical component, and the range will be calculated by horizontal component. So what is the velocity along horizontal? This much. What is the total time taken in the journey? It is equals to time of flight, which is 2u sine theta by g, which is 2u sine theta by g. We have already seen this. Yes. Okay. Clear? So now the range will be distance, and distance you know is velocity into time, because range is the distance which is covered along the horizontal interval time of flight. So I am multiplying the velocity with the time along horizontal to get the distance along horizontal or the displacement along horizontal. So it will be u cos theta into 2u sine theta over g. So it will be u square 2 sine theta cos theta by g. And you know 2 sine theta cos theta is nothing but sine 2 theta. It is an identity that sine 2 theta is equals to 2 sine theta cos theta. So that is the range. 2 u square sine 2 theta by g. U square sine 2 theta by g. That is the case of range. So we have seen three things. Range, maximum height, and time of flight. What was maximum height? Remember, u square sine square theta by 2g. What was range? It was u square sine 2 theta by g. And what was time of flight? It is 2u sine theta by g. So it's not necessary to learn these formulas. Not necessary. If you know how to bifurcate the projectile motion into vertical as well as horizontal, then you will be easily able to solve all the questions. That is the point. So I think the basic concepts are clear about the time of flight, horizontal range, maximum height attained by the projectile. What are the basic conditions in a projectile motion? I hope these all quantities are clear to you. Okay, done. Now question is there that read the question. A football is kicked with an initial velocity 25 meter per second. So the initial velocity given to a projectile is 25 meter per second. That is u according to our convention. At an angle of 45 degree with the horizontal. So the angle with the horizontal is 45 degrees. So according to us, theta is 45 degree. Determine the time of flight, horizontal distance, and peak height of the football. And we know all these formulas already. What is time of flight? It is 2u sine theta over g. What is horizontal range? It is u square sine 2 theta by g. And what is maximum height? It is u square sine square theta over 2g. So all the formulas are available. You know g, you know u, you know theta. So can't you calculate these? Take g as 10. You can take g as 10 meter per second square approximately to solve the questions. So you will be easily able to find all these values, yes or no? Just put the values of u and theta and g, and you will get all the three quantities, that is time of flight, horizontal distance, and the peak height of the football. Question is clear? Yeah, formula based question. Okay, so you can do that. Okay, you can solve this numerical. Okay, now see, condition for maximum range of projectile. What is the maximum range or maximum height of the projectile? It's not for maximum height, is actually misprinted. It is for maximum range. For maximum range, that how far the projectile will go, that is decided by which condition. So we know the range of projectile is given by, what is the formula? Remember, u square sine 2 theta by g, u square sine 2 theta by g. And you know, for a given projectile, u can't be changed. For a given projectile thrown with a particular velocity, u can't be changed. G is also constant, that is 9.8 meter per second square. Now we can see what this angle will give you. Actually sine 2 theta. So can I say range will be maximum when the value of sine 2 theta is maximum? Yes or no? Because range is directly decided by the value of sine 2 theta. So if the value of sine 2 theta is maximum, then the range will be maximum. Yes or no? So the maximum value of sine is 1, if you know. The maximum range of sine function is 1. So when is the value of sine 1? It is 1 at an angle of 90 degrees. So can I say sine 2 theta will be equal to sine 90 degree, because it is equal to 1 and 1 is the value of sine 90. So can I say sine 2 theta will be equal to sine 90? So can I say 2 theta will be equal to 90 degree? And from this we can say theta will be equal to 45 degree. So if I throw a projectile, at an angle of 45 degree with the horizontal, then the range of the projectile will be maximum, because the value of sine 2 theta will be then 1. Sine 2 theta means sine 90. So the range will be maximum u square by g. So maximum range is given by u square by g. U square by g. That is the formula for maximum range, and maximum range will occur at an angle of 45 degree. Yes, at an angle of 45 degree. I think the concept is clear, that maximum range is given at 45 degree. And you can also see from this diagram, the person is throwing the ball at different angles. You can see yellow is 10 degree angle. This is the motion for 30 degree, then 45 degree, then 60 degree, then 80 degree. So in the case of 45 degree, you can see the ball is going farthest. The ball is going farthest, or you can say the range is maximum. Range is maximum at this angle of projectile at 45 degree. And you have seen that how is coming 45 degree for maximum range. How theta is coming as 45 degree for maximum range, that you have already seen. Okay. Now let's see, that is the thing. We was talking about trajectory of projectile. So trajectory is the path taken by the projectile. Okay. Trajectory is the path followed by the projectile or path taken by the projectile. That is known as trajectory. So that is the curved path. That is the curved path. So we want to find the basic equation of this trajectory. If I want to find the basic equation of this trajectory, so what can I say? Can I define a general point xy? Can I define general point xy if I am taking this point of projection as origin? I am taking this point of projection as origin. So this is x-axis. This is y-axis. So along x direction, if I apply second equation of motion, can I say s equals to ut? What is velocity along horizontal? It was u cos theta. X equals to ut plus half at square. And you know acceleration along x direction is 0. That is half at square. What about y direction? Suppose the distance covered in y direction is y. So that will be ut, that is u sin theta into t, plus half. What is acceleration along y direction? It is minus g. We have already discussed that it is minus g for a projectile. So it will be u sin theta minus half gt square. So from this equation, what can you see? X equals to u cos theta into t. And you can see t is equals to x by u cos theta. T is equals to x over u cos theta. So if I put this value of t in this second equation, in this equation second, what will I get? See what will I get? I'll get y equals to u sin theta. What is t? X over u cos theta. X over u cos theta minus half g t square, means x over u cos theta whole square. So can I say this u and u will get cancelled out, and sin theta by cos theta is nothing but tan theta. So it is x tan theta minus half g x square over u square cos square theta. So this is the equation of projectile that and for any general point xy. For any general point of xy, this is the equation of projectile, or I can say equation of trajectory. Equation of trajectory or path followed by projectile. So this is basically, if you compare it with the standard equation, it is coming as the equation of parabola. Equation of parabola. So that's why we say the path taken by the projectile is a parabolic path. The path taken by the projectile is a parabolic path, which is decided by this equation. That is the equation of trajectory of the projectile, or you can say the path followed by the projectile. That is the basic meaning of trajectory. So we have seen that equation is coming as y equals to x tan theta minus half gx square over u square cos square theta. Clear? Thumbs up, guys. So I think you are enjoying the lecture. We have seen different things about projectile. What is horizontal range? What is time of flight? What is maximum range? How different components of velocity are deciding different values. Yeah. Then we have seen the condition for maximum range, that is 45 degree. Then we have seen the equation of trajectory of projectile, which is coming as a parabolic trajectory. That's why I am saying the path of the projectile is parabolic. So I think these types of things are clear according to projectile. Okay. Now see some questions again. An object is launched at a velocity 40 meter per second. So initial velocity is given as 40 meter per second at an angle of 50 degree upward with the horizontal. So always we calculate angle with the horizontal. So theta is given as 50 degree. So what he is asking? He is asking for maximum range, horizontal range, or not maximum, actually horizontal range. So, and you know the formula for horizontal range was what? Yeah, it was u square sine 2 theta by g. So you know the value of u, that is 40 meter per second. You know the value of theta, that is 50 degree. You know the value of g, that can be taken as 10 meter per second square. So can't you be able to calculate range? You will be easily able to calculate the range. Clear? So this is a perfectly formula based question. Now see second. Now the question is same, the answer part is different. That what is the maximum height reached by the object? So you know the maximum height reached by the object is given by u square sine square theta over 2g. You know the value of u, that is 40 meter per second. You know the value of theta, that is given as 50 degree. So by putting the values of u, theta and g, you will get the answer. You will get the answer. Clear? Now third, the question is same, the data is same. He is asking time of flight. And you know time of flight is 2u sine theta by g. Time of flight is 2u sine theta by g. And u, theta, g are all given. The question is same, the parts are different. The data is same in all the three questions. So you can see, you can easily find all the three things: time of flight, horizontal range, and maximum height. Okay. Now I think the basic concepts are clear, that how to bifurcate the projectile into two parts, that is horizontal, vertical, how to calculate. If I repeat, if I summarize, the time of flight and maximum height is decided by the vertical component of projectile, that is u sine theta, and horizontal range will be decided by the horizontal component of velocity, that is u cos theta. Okay. And for maximum range, theta should be 45 degree, or I can say angle of projectile should be 45 degree. And for a projectile, the trajectory is a parabolic trajectory, as we have seen from the equation. The important thing, that in a projectile motion, horizontal acceleration is 0 and vertical acceleration is equals to acceleration due to gravity, that is small g. Yeah. And we are neglecting the air resistance for the projectile motion, because near to the surface of Earth, air resistance can be neglected. Okay. So I think all the basic concepts are clear. Okay. So in case of any doubt still, you can refer to the Ask IITians website. There is a doubt forum there. You can post your doubts there and get it resolved by our expert faculties. Okay. So we will end the lecture here. So thank you so much. Stay safe and enjoy. Okay, guys. Thank you. Bye.